Hi, my name is Blaine Bettinger. I wanted to talk to you today about the issue of sharing different amounts of DNA with the same cousin at different testing companies. Now, if you have the same match at different companies, you've probably experienced something like this, where they might share 85 centimorgans with you at FamilyTreeDNA, but they share only 70 centimorgans at GEDmatch and maybe 55 centimorgans at AncestryDNA. Why do we see those different amounts? Shouldn't they all be the same exact amount? If it's the same cousin that's being compared, their DNA to your DNA, shouldn't they all be the same amount? Well, let's look at this from a real-life example. Luciana, who is, this tree is artificial, but the match is a real match, and she is approximately a fifth cousin. Luciana and I are fifth cousins, and we have both tested at 4 different companies and transferred our DNA to GEDmatch. So what we're going to do is we're going to compare how much DNA we share at 23andMe, AncestryDNA, FamilyTreeDNA, GEDmatch, and MyHeritage. Will the amounts be the same, close to each other, or different? And if they are different, what are some of the reasons why they might actually be different? First, we'll talk about 23andMe. Luciana at 23andMe, she is, as you can see, a predicted third to fourth cousin. She shares 0.81%, which translates to 60.13 centimorgans at 23andMe. And as you can see, she shares 4 segments with me. If we go to the chromosome browser at 23andMe, we can see the actual segments. So those 4 segments break down like this. There are 2 segments very close to each other on chromosome 5. One is 17 centimorgans, one is 15. There's a very small segment on chromosome 7, and there's a large segment on chromosome 21. So those are the 4 segments that 23andMe identifies Luciana and I sharing in common. And that adds up to 60 centimorgans. Okay, well, now let's look at Ancestry. At Ancestry, we're predicted to be 4th cousins in the range of 4th to 6th cousins. And as you can see, now we have a substantial difference. Now we have 48 centimorgans instead of the 60 we had at 23andMe. We are still at 4 segments, however. Now, to get the AncestryDNA segment information, as you probably know, we don't get segment data from AncestryDNA. So we don't know how these segments compare to the segments we have from 23andMe, for example. Okay, at FamilyTreeDNA, Luciana is predicted to be a 2nd cousin to a 4th cousin, and now we have significantly more segments. We have 76 centimorgans that we are predicted to share. And when we look at the chromosome browser, that works out to 3 segments, although there's a little bit of a hitch there that we'll talk about. So at a threshold of 6 centimorgans or greater, we share actually 48 centimorgans. So that's a big difference, right? If we go back a slide, we see we share 76 centimorgans here, but when we actually look at the chromosome browser, these are the only large segments we share. And actually, if you use the chromosome browser at FamilyTreeDNA, what you'll see is that FamilyTreeDNA includes a lot of the smaller segments that boost up that number. So if I included all the segments of, say, 1, 2, 3, 4, 5, and so on centimorgans, it bumps it up from where it is now, from 48 centimorgans up to a total of 76 centimorgans. So that's one of the major reasons we see differences from one company to the next, is the thresholds they use. Okay, let's go to GEDmatch. Now, at GEDmatch, using the 1-to-many comparison, Luciana and I share 72.9 centimorgans. If we look, that's the 1-to-many, meaning this is the fishing tool at GEDmatch to find all of your matches. Here is the 1-to-1. So, for example, we could click on the little A there that's hyperlinked, and that will bring us to the 1-to-1, Luciana and I. When we do that, we get a total of 63.4 centimorgans when we add up these 4 segments. So the differences there are due to the different thresholds and different analysis that are done. But what we can see is that 63.4, for example, is very similar to what we got at 23andMe. The segments are pretty similar too. We have the 2 segments close to each other on chromosome 5, the small segment on chromosome 7, and then the large segment on chromosome 21. Now, at MyHeritage, we are predicted to be third to fourth cousins. We share 66.7 centimorgans, or 0.9%, and that's across 3 segments. Now, if you've been keeping track of the segment sizes, you can see it says the largest segment here is 37.6 centimorgans, and that's much larger than the segments we've seen in the other ones, and we'll see why that is in just a moment. So when we look at the segment information for MyHeritage, remember it said there are 3 segments, and what we see is that what MyHeritage has done is combined the 2 segments on chromosome 5. So instead of having those 2 smaller segments very close to each other, which very likely could be a single segment, here they've combined it into a single segment. So we have now a large segment on chromosome 5, that small segment on chromosome 7, and that large segment on chromosome 21. But that adds up to the total of 66.7 centimorgans from MyHeritage. Okay, well, now what we can do is we can look at the different amounts from the different testing companies. So we have a total of 60 centimorgans from 23andMe, 48 from AncestryDNA, 76 from FamilyTreeDNA, or 48 if we subtract out the small segments. At GEDmatch, we have either 72 or 63, depending on which tool we're using, and at MyHeritage, we have 66.7. So as you can see, we are getting some very different numbers. Now, some of the reasons why they're different, for example, is AncestryDNA can underestimate the total due to an algorithm called Timber that will downweight some segments. So for example, Timber, what it does is it looks at segments that are overrepresented, meaning you match more people than you realistically should on that segment, and so it will downweight that segment. So what that has the effect of doing is lowering the amount of total centimorgans that you share with another match. And as we can see here, indeed, the 48 centimorgans at AncestryDNA is among the lowest. Also at FamilyTreeDNA, they were among the highest with 76 centimorgans due to the fact that those small segments were included. So there are various reasons. Some of the other reasons why we see differences is because, for example, MyHeritage uses something called imputation. Imputation is where it uses population genetics to sort of fill in the gaps in areas that are not as in between tested SNPs. And so sometimes that can have the effect of bumping up the numbers, usually making them higher, but sometimes causing breaks and other issues. So there are a bunch of reasons. Another reason is that that starts and stops are fuzzy. So because the SNP chips that are used are sampling the genome rather than sequencing all of our DNA, it's really hard for the company to tell exactly where a shared segment of DNA will start or stop. And so they will they have their own algorithms for determining where a segment starts and stops. And if there's a little bit of difference there, then that can result in a change in the segment size. That's usually going to have a much smaller effect than some of the other things like Timber or small segments or imputation, for example. One of the most common questions I hear is, which of these numbers is right? Which should we use for our analysis, and do these differences matter? As you can see here, again, we are talking about a pretty big range. From a low of 48 centimorgans to a high of 76 centimorgans, that's a really big difference. And so the question of which we should use is, in fact, an important question. Well, does it even matter? Is this an important thing to consider, or is it something we should largely ignore? Well, it can make a difference if the differences are large enough. Meaning, if we are seeing a big difference from the lowest to the highest, for example, it can make a difference. So let's look at relationship predictions using these numbers. All right, so here, for example, what we've done is we've gone to DNApainter.com and we have used these relationship probability tools to give us an idea of the various relationships using the smallest number. So the smallest number was from AncestryDNA, probably as a result of that downweighting from the Timber algorithm we talked about. So what we can see here is it gives us about a 30% probability of relationships like half third cousin once removed, half second cousin twice removed, second cousin 3 times removed, and so on. It also gives us about a 25% probability that it's a more distant relationship, on the order of a fourth and beyond. All right, well, that's the smallest number. Let's look at the largest number, which was 76 centimorgans. Now, we really shouldn't be using that number at all because we know we need to take out those small segments, but we could use even if we use just 66, which was the number from GEDmatch, for example, would be very similar to this. And as you can see, we get a 32% probability of relationships like third cousin, half second cousin once removed. So what has happened is that using the larger number has pushed some of the relationships up to a higher probability. So looking at third cousin on the left, for example, we had a 15% probability. On the right, it's now a 32% probability. Now, in reality, that probably seems like a bigger difference than it really is in practice. What I mean by that is, once we get down in the range of 75 to 50 centimorgans or so, these fit into a lot of different categories. In fact, it fits into all these categories we see on the screen. And as a result, while some relationships are going to be more likely than others, we still need to consider all these relationships as possibilities. And that's one of the problems of relationship predictions. So although we do want to try to use a number we think is the most accurate, maybe in the middle of the range if you're actually able to test at multiple companies, at the same time we need to realize that it is not going to give us a level of accuracy that will allow us to do more than we can do with it anyway. Meaning we still have to do all the research. We have to do the genealogical research and add the DNA in. It's not as if the amount of DNA at this range is going to make us that much more confident in one relationship or another. It's still going to be within a lot of different ranges. So hopefully that gives you some very quick ideas of why you might be seeing different amounts at different companies. See how it can vary from one company to the next, and gives you a feel for what you might do and understand with those different amounts. Thank you very much for joining me.